Today we're going to do 2.8. It is going to involve some graphing. We're going to be those inequality signs, less than, greater than, less than or equal to, greater than or equal to. We're going to be graphing those, but it's going to have two variables, which means it's going to graph to be lines, and we're even going to do some absolute values. So this right here is kind of an example of what we're going to be seeing. So let's try an example. The first thing I want you to do is get it into y equals mx plus b form. So I should have y, or I have here this 3x plus a half y is less than 2. The first thing I'm going to do is get rid of the 3x by moving it to the other side. Now the issue is, oops, I'm sorry, try that again. I can't have 2 and negative 3x combined because they're not like terms. So I'm just going to put negative 3x plus 2. And the reason I chose to put the negative 3x first is because I'm looking for y equals mx plus b form. That's what gets me the closest. So then what I'm going to do is try to get rid of the half. I'm going to do that by multiplying by the reciprocal or multiplying by 2. I'll be multiplying the entire other half by 2 to do this. And that's going to give me, let's see, these cancel. And then that's going to be negative 6 plus 4. Ooh, my pen didn't go for some reason. So now what I'm going to do is graph that like it's a normal line. So I'm going to go to the y-intercept first, which is 4, and I'm going to put a point. So 1, 2, 3, 4. And then from there I'm going to do my slope, which is negative 6, which means I go down 6. 1, 2, 3, 4, 5, 6 over 1. Now when I connect these, there's going to be a special rule. Do you remember I had the less than or greater than signs and the less than or equal to and the greater than or equal to sign, and I talked about circles versus dots, extra ink, extra ink. Same thing's going to happen here, and here's going to be the trick. If it is a less than or a greater than sign, it's going to be a dashed line, and the equal to sign is going to be a solid line. So as I look at this one, I see that it is just a regular less than sign, so that means when I connect these, it does need to be a dashed line. Now, if you remember when we were graphing the inequalities that were on a number line and we did the circle versus dots, we shaded it one direction or the other. Well, we need to figure out what direction is this going to shade. So here's what I do. I pick a point anywhere on the graph to plug it in. You can use any point as long as it's not on the line. My favorite point to use, honestly, is 0, 0, because things cancel and it's awesome. So if I plug in 0, 0, I have 0 is less than negative 6 times 0 plus 4. So negative 6 times 0, that cancels. That's why I love using 0. And so now I have 0 is less than 4. Ask yourself a question. Is 0 less than 4? If the answer is yes, then you can put like a check mark or star at 0, 0. And if the answer is no, put an X. And here's the thing. You shade towards the stars, the check marks. You shade away from the X's. So since this one's shaded towards, I can go ahead and shade it on this side. All right, let's try another one. Let's try 1B. We'll do that. So first thing I notice is that it is in the wrong order. So I'm going to go ahead and add X to both sides. So I have 2y is greater than X plus 4. And I divide by 2. That means I divide everything by 2. Now graph it like a normal line to start with. So up 2. Oh, that was not very on, was it? There we go. Down 1 over 2. Down 1 over 2. Backwards. Up 1, left 2. Up 1, left 2. There we go. Extra ink, extra ink. So this one should be a dashed line. It does not equal the line. Now ask yourself, does the line go through 0, 0? The answer is no, so I'm going to plug in 0, 0. 0 greater than 1/2 times 0 plus 2. Of course, 1/2 times 0 is just 0, so I have is 0. And here's the thing, if it helps, you can write like a little question mark here. Is 0 bigger than 2? No, that's an X. Okay, remember I said shade towards the check mark stars, shade away from the X. So this time, I'm going to shade up here. Why don't we do an absolute value example, and then we'll probably call it a day. So how about 3B? Why not? I say graph, you say table is how we're going to do this one. And again, in the middle, it gets to be a -1, -2, -3, 0, 1. So I plug all these in. -3 plus 1 is -2. That becomes a +2, and 2 times 3 is 6. Plug in -2. -2 plus 1 is -1, which becomes +1. 1 times 3 is 3. -1. -1 plus 1 is 0. The absolute value of 0 is 0 times 3 is 0. 0 plus 1 is 1. Absolute value of 1 is 1 times 3 is 3. 1 plus 1 is 2. Positive 2 is 2. 2 times 3 is 6. Check it out. My table mirrors. Rock on. Plot them. So -3, 6. -2, 3. -1, 0. 0, 3. Up like that. And extra ink, it does look like this time I get to do a straight solid line. A little off my points, but it's hard to do that with technology. And now I'm going to decide which way it shades. So again, does it go through 0, 0? No? Great. Plug that in. Is 0 greater than 3 times the absolute value of 0 plus 1? Well, 0 plus 1 is 1, and 1 times the absolute value of 1 is 1, and 1 times 3 is 3. Is 0 bigger than 3? No. So in this case, I'm going to shade inside, oops, like that. Hey, when you get to Delta Math, make sure you read the directions or watch his help video if you're having troubles figuring out how to plug the answer into Delta Math.